Okay, so for this homework on the 30th of January 2019, we're starting at question 10 and working to the end of the Unit 1 paper, and we're starting at question 11 on Mr. Lloyd's video and working to the end of that paper. So the non-calculated paper, picking up at question 10, Kerry has a set of cards. Each of her cards is labelled north, east, south and west. Kerry chooses one card at random from a set of cards. Complete the following table. The probability of Kerry choosing a card labelled west. Well, as the cards have got a label on them, everything in this table must come to a grand total of 1. So all 4 numbers in that table must add up to a grand total of 1. So far, they come to 0.85. So 1 minus that 0.85 is telling me I have 0.15 for the west card. Kerry chooses one card at random from her set of cards. What is the probability that the card is labelled east or south? In probability, when we see the language or, we need to think of adding, putting these probabilities together to say one or other. So that's east or south. So the answer will be 0.45 because they will be added together. And for the last part, Sarah has an identical set of cards. Kerry and Sasha, each choose one card at random. What's the probability that they both choose a card labelled north? So that's going to be a north from Sasha and a north from Kerry. This time, different language. The word and means that we're affecting the probability, so this will be multiply. And in a probability question means that you're going to be multiply. Think of the language and think how or, add, and multiply. That's always the same every time you use probability. So the probability of Sasha having north is 0.4 and Kerry having north is 0.4, and 0.4 multiplied by 0.4 is 0.16. Question 11. So here we need to complete a table to draw a quadratic graph. A quadratic graph has an x squared in the equation, and a quadratic graph is always, or generally, the U shape, or in some very rare cases, an N shape. But I got a feeling we're going to have a U shape, this one, in our question because that x squared is positive. So we're looking for the graph on the worksheet underneath, on the grid underneath, to be a U-shaped graph. But first we need to complete the table. We've only got one value to add to the table, this one. So we need to complete that equation with 3 in as our x value. So where it says x squared minus 5x plus 2, we are going to do 3 squared minus 5 times 3 plus 2. So knowing your squared numbers, 3 squared is going to be worth 9. Subtract 5 3s are going to be 15 plus 2. 9 take away 15 is minus 6. Minus 6 plus 2 is minus 4. So the value in that table is going to be a minus 4. Okay, on this grid you've got to be careful to make sure you put your plottings in the right place, but also that when you go through them then to join them up, you're actually making contact with those points. Not just getting close, but having a nice curve, going through those points, even if your curve is a little bit wobbly or a little bit offline. First one across to minus 1 up 8. Across to minus 1 up 8 will be there. Second one across to 0 up 2. Third one across to 1 down to minus 2. Across to 2 down to minus 4. across to 3, also minus 4, 4 minus 2, and the last one, 5, positive 2. So I can see that shape mapped out between my points. I can see the U shape that I predicted at the very beginning. But what you need to make sure is that you are definitely making contact with every one of those coordinates. You can join it up, even if you do it point to point like I am, so it's not a completely continuous curve when you're drawing it. Nobody will know, and you won't lose marks for missing one of the actual plotted points. So if I drew that line now and I missed that point completely, I'm going to actually gamble by losing possibly one of the marks. So you must make sure that you are in contact with each of those points you've just plotted. And there's your quadratic, the U shape that we saw at the top of the page. Okay, last part of the question in part C tells you that you've got another line, y equals minus 3. The line y equals minus 3 on the axes goes across at minus 3, cuts through the y-axis, here's the y-axis, at minus 3. So this here is the line that I'm interested in. I'm going to add that to my graph, and I'm going to see what the x values are where we make contact. So here on my graph paper, I'm going to add on now the line at minus 3. Right, minus 3 is here, halfway between minus 2 and minus 4. And then with my ruler, I'm going to draw on the line. I can see that I make contact in two places, here and here. And they're looking for me to write down the x values. So I'm going to go straight up from both of those points to work out where we're meeting the axis. This one is going to be at 1.6, and this one's going to be at 3.6 as well. So 1.6 and 3.6. 1.6 and 3.6. Question 12. Question 12 asks us to break 700 down into a product of its prime factors. So starting with 700. Dividing it by 2 will make 350. Dividing it by 2 will make 175. Dividing it by 2 again can't do. So now I try something bigger. 3 won't go into this, I can tell, because if I add 1 and 7 and 5, I get 13. That's not in the 3 times table, so I can't divide this by 3. So I'm going to divide it by 5. 5 into 175 goes 35. 5 into 35 goes 7. 7 into 7 goes 1. So 700 as a product of its prime factors in index form will be 2 to the power of 2, because we have 2 of them, multiplied by 5 to the power of 2, because we have 2 of those, multiplied by a 7. And I can see that from running down the list of dividers. The list of dividers that I needed to use until I ended up with 1. This is a non-calculator exam, so this looks really scary for part B, this number, this really large number, but knowing that it's going to equal 2 to the power of 25 means that I really don't have much to do. It says explain how this tells you that this is not a square number. And square numbers have very special powers, and 2 to the 25 is the clue. So here's my problem, or my clue, that power of 25. So I'm going to write here, because it does not have a power, which is an even number. Because for this to be a square number, the power would have to be an even number. So 2 to the 26 is a square number, but 2 to the 25 is not. So there's my little example as well, so that they know that I really do understand. Question 13. I've got a straight line graph, and it's asking me which one of the following equations could represent the line on the above graph. Circle your answer. Well, the first thing I notice is that the slope of this graph is negative. A positive graph would have had a positive gradient. So positive, ours negative. So as I'm looking at the different equations that are on offer, no good, no good. This doesn't go through the origin, and this line here would have to go through the origin, so no good. This line here cuts through at -2, this line here cuts through at +2. So both of those are negative lines, both of them are a good option. This one cuts through at a +2, so I think that that's the line that I've got. Part B, which one of the following points lies on this new line here now, 2y equals 3x plus 4. Circle your answer. Well, these are x and y coordinates. So if I've got x and y coordinates, one's an x number, one's a y number. When I put the x number in, the y number should come out. Or when I put the x number in on the one side, it should give me the y value on the other. So, for example, I'm going to try this one here, 5, 2, to show you what I'm thinking. So if I put it into the 2y part, that would give me 2 times 2. And on the other side, the 3x plus 4 part would have to be 3 times 5 plus 4. So this side is worth 4, this side is worth 15 plus 4. Is 4 the same as 19? No. So this is not the one we wanted. So 5, 2, no good. Now, as I'm looking at the other coordinates, let's try 2, 5. On this side, 2y would have to be 2 2's. Again, sorry, 2 5's. So I'm just going to write down the 10. On that side, 3 times the x value plus 4. That's going to give me 3 times 2 plus 4. 3 times 2 plus 4 is worth 10. So that one is going to work. You would have to work through each of these and cancel them out until you found the right one. And we were looking for the left hand side to equal the right hand side. Part C, this line here has been drawn and we don't have the equation for it, but we're asked to find the gradient of the line. To find the gradient we need a right angle triangle, and we have one here just around the origin, and we can use that to find the gradient. The gradient of a line is a division of two parts. So we need the difference in the x direction, and we need to divide it by the difference in the y direction, and we need to divide it by the difference in the x direction. So if you have a look, this is the y direction here, and we have a difference of 2. And here is the x direction here, and we have a difference of 3. So this has gone up by 2, from -2 to 0. This has gone across to 3, from 0 to 3. I'm looking for 2/3 in the options. This is definitely a positive line, so don't be confused. It can't be -2/3, as that would have to look like the line in the first diagram. So it is 2/3 and it would be positive. Question 14. When you're given clues or a question built around clues like this, you do need to have a look at all 3 clues, because to get the 3 marks you don't have to have done everything. If you've just done clue 1 and clue 2 to the best of your knowledge, you may have got 1 or 2 of the marks before you leave the question. Don't give up. Try every individual part. Think of the clues a bit like bullet points. Work through them one at a time. So a whole number is written on a card. You are given these clues to work out what that number could be. Clue 1 is double the number is between 8 and 18. If that's double the number, so the number itself would be half. So 4, 5, 6, 7, 8, or 9. From clue 1, if these are my numbers, then double in each of them would give me an answer of 8 up to 18, inclusive. So including possibly 8 and possibly 18. Clue 2 tells me that I need to be dealing with prime numbers. Nothing divides into a prime number, so as I think about that list of options, some of the options I can cancel straight away. That's in your 2 times table, that's in your 2 times table, and that's in my 3 times table. So after clue 2, I've only got 5 and 7 left as possible answers. And then clue 3. Clue 3, the number is not a factor of 100. This means it will not divide into 100 exactly. Now, 5 goes into 100 exactly 20 times. So this tells me that I'm definitely, out of the 5 or the 7, picking the 7. So the number on the card is a 7. Not too scary. You just need to work through the clues one by one by one. Question 15, dimensions. Now we're looking for 3 different scenarios when we come in front of my dimension questions, and I'm going to make a note down here for you on the bottom. 1 dimension, or 1 direction, as you might want to think of it, is a length formula. A length formula will have 1 letter in each of its parts. So it may be made up of more than 1 part. So it might be 5D plus 4E, but you will only have 1 letter in each part of the formula. 2 dimensions or 2 directions will be an area formula, and then we'd expect there to be 2 letters in each of the parts. So XY plus 7CD, 2 letters here, 2 letters there, plus P squared, 2 letters there as well. So an area formula has 2 letters throughout every individual part. 3 dimensions or 3 directions will be a volume formula, and a volume formula would have 3 letters. And like the others, those 3 letters or 3 letters would need to be included in every part of the formula. If you have a formula that is a mixture formula is a load of rubbish, and it's none of these. They normally throw 1 rubbish equation in to catch you to make sure you're paying attention. So 3 letters could be a cubed, that's 3 Ds. Take away 7R squared H, 2 R's and H, that's also 3 Ds. So there's a formula for area, volume. So we have length, we have area, and we have volume. And you've got to be able to count the number of dimensions in an equation or in a formula based on just looking at the letters. So if you look at the first one now, 3 Ds here, 2 Rs there, and a H, 3 by 3 volume. 2 Ds here, a H and a W there, 2 and 2, 2's everywhere, so area. Just a D, just a W, just a H, one direction everywhere, so length. 1 R there, 2 R's here, that's a mixture, so if it's a mixture, it's not area, length or volume. And then this is a bracket, so before I can do anything I need to multiply out the bracket. First part of the bracket is really DW, second part of the bracket is really HW. 2 there, 2 there, 2 dimensions for area. D cubed in the last one is 3, DWH in the last one is 3, 3 everywhere is volume. So that page makes good revision, but I will do a Revise With Me booklet looking at a few more formulas. I'll do that this week. Question 16, one of our favourites. So we've got a Venn diagram, but this one's a bit nasty because it's going to involve a little bit of algebra. So here we have 20 people who visit Anglesey for a weekend break. So the entire diagram has to include 20 people. 10 of the people go and visit Beaumaris Castle. So 10 of the people are in this circle. Problem I have is that I don't know if it's all 10 of the people in this part, if it's all 10 of the people in this part, maybe it's 5 by 5, I just don't know yet. 13 of the people visit the lighthouse, so in a similar way, 13 people are in that circle. I don't know if it's 10 and 3, 3 and 10, 5 and 8. All I know is that the total for the lighthouse is 13. I am told that 4 people, this I can use, don't go to either place. So in this outside space, we've got 4 people. But that's the only number I can put on that diagram at the moment that I know is absolutely correct. So if there's 4 people outside, the 2 circles must come to a total of 16. Because if I take away the 4 people that are outside, the people who visited the castle and the lighthouse actually comes to a total of 16. But if I add up the castle and the lighthouse visitors, that comes to 23. So I have 23 people visiting the castle and the lighthouse, but actually only 16 people in the diagram. This comes about because some of the people have been counted twice. So if the person went to both of them, the lighthouse and the castle, they actually ended up being counted in the picture or counted in the information twice, but they'll only be in the picture once. So how many people were counted twice? 7 people were counted twice. So those 7 people put their hands up for the castle and then also put their hand up for the lighthouse. So they got counted in both questions. It says here that we have 10 people who visited the castle. Those 7 people were counted twice, but there was another 3. Tells us here that we've got 13 people who visited the lighthouse. Pardon me. That's the 7 people who were counted already and an extra 6. So be careful, please. This is a Venn diagram where this information doesn't get used directly in the question. You have to think about it because some of the people were counted twice. Part B of the question. One person is chosen at random. What's the probability that the person visited only one of the 2 places? There are 20 people altogether. There are 3 people who only visited the castle and 6 people who only visited the lighthouse. So there are 9 people that you can choose from that only visited one place. Question 17, simultaneous equations. No pictures, no strange setup, just a nice straightforward pair of equations to solve. So I'm going to run through the method and I'll label my diagram, label my equations and run through them step by step. So as I talk about equation 1, as I talk about equation 2 and so on, I'll label them there. I like to make the x's match so that we can eliminate x's and find the y answer first. So to eliminate the x's, I'm going to need to make them the same amount. Equation 1 will need to be multiplied by 2. Equation 2 will need to be multiplied by 3. This will allow us to have 6x in the first equation. Everything has to be multiplied in the same way, so all of the numbers change, giving me a brand new equation. I'll call it 3. 6x in the second equation, when I multiply it by 3. Everything in the second equation has to be multiplied by 3, so I have a new equation again. I'll call it 4. We are looking to eliminate the x's, to get rid of the x's, so we have to do a combination now, either adding or subtracting, so that this pair of equations is combined and the x's would cancel out. So I'm going to do equation 3, take away equation 4, and I will do this just underneath. So equation 3, take away equation 4, and it's going to work like this. 6x, take away 6x, will leave us no x at all. 8 minus 9. So think about that for a second. 8 minus 9. Where we've got the double negative, 8 minus 9, is actually going to leave us with 17y. Equals, and then on the other side we have 14 minus 38. And 14 minus 38 is going to give us minus 34. 17y equals minus 34. Dividing both sides by 17, y is going to equal minus 34 over 17, which is minus 2. That's only half the work, because we needed to find the x and the y value, and so far all I have is that the y value is minus 2. So I look back to the original equation. I'm going to pick equation 1, and I'm going to substitute in the fact that y equals minus 2 into that original equation. So originally 3x plus 4y equals 7, but now I know that that y is actually a minus 2. So this 4y is actually not 4y, but 4 lots of minus 2. So 3x plus 4 lots of minus 2 equals 7. 3x minus 8 equals 7. Adding 8 to both sides, 3x must equal 15. Dividing both sides by 3, x equals 15 shared by 3, which is 5. So x equals 5. Question 17 and question 18 to finish the paper. 18 and 19 to finish the paper. Question 18, calculate the value of, and this is standard form, but it's an addition. The best way to deal with an addition of standard form is to write the numbers out in ordinary form, line up the place value, and then change it back. So this power of 5 here is telling me I have 5 multiples of multiplying by 10 to deal with. The first 2 will clear the 4 and the 1. So then there'll be 3 zeros, because the power of 5 clears those 2 and 3 zeros. And this power of 4 here tells me that I'll clear that 2, that 3, and then I'll need 3 zeros. Now it's difficult to see how they line up with the addition written that way. So if I write it underneath, line up the 3 zeros, put the 2 and 3 in place, then I can see 0 plus 0, 1 plus 3, 4 plus 2, 5. So in ordinary form, those pair of numbers adds up to 564,000. Putting that back in standard form as the question asked, 5.64 times 10. I need to clear these 3 zeros and those 2 decimal places to put the decimal point in where I want it between the 5 and the 6. So that's 1, 2, 3, 4, 5, power of 5. Question 19. Rashid owned N sheep. Ivion had exactly 4 times as many sheep as Rashid is. Rashid buys 17 extra sheep. Ivion sells 8 of his sheep. Oh, crumbs. But Ivion still has more sheep than Rashid. More than. Okay. Form an inequality. Solve the inequality. Show all your work in. Okay. So Rashid, to start off with, had N sheep. And then he buys an extra 17. So Rashid has N plus 17. Ivion started off life with 4 times as many sheep, but then he sells 8. We're told that Ivion has more sheep. 4n minus 8 is more than Rashid's. And here is my inequality that they wanted me to form. The more than being the key word to make it an inequality. And now they want me to solve it. So the first thing I'm going to do is take away n because it's the smallest number of n on both sides. Please note it works just like an equal sign. I've just now got that more than symbol in the middle. Second step that I'm going to do is I'm going to add on 8 to get rid of the minus 8. So adding 8 to both sides. 3n greater than 25. Dividing by 3. These steps look the same as they do for a normal algebra sum because it does work in exactly the same way. 25 over 3. That's going to be 8 with the remainder 1. But obviously n is the number of sheep. So n has to be greater than 8 remainder 1. So n, the number of sheep, must equal 9.